Welcome to this explainer. Today, we're going to track the absolutely fascinating life cycle of a modern application, taking it all the way from raw code to a robust, scalable deployment. If you've ever found yourself wondering how major web services manage to stay online 24/7, even while constantly updating their software behind the scenes, well, you're in exactly the right place. We are going to unpack exactly how Kubernetes makes that magic happen. Here's our quick step-by-step roadmap for today. We'll kick things off with Minikube and Kubernetes basics, deploy your very first app, and then expose it using load balancer services. Next, we'll scale up your replicas, execute some zero downtime rolling updates, and finally, clean up our resources. We'll cover the core theory and immediately back it up with the exact practical commands you need. Let's get right into it. All right, Section 1, Minikube and Kubernetes Basics. Let's lay down the foundational environment where our application is actually going to live. So before we even type a single command, we really have to ask ourselves, why do we even need this? Well, the answer is pretty straightforward. It's all about deploying, scaling, and updating containerized applications 24/7 without a single second of downtime. Modern users expect zero interruptions, right? And developers, they need to push updates multiple times a day. Kubernetes is basically the production-grade orchestration platform that handles all the complex scheduling and distribution of these containers, so you absolutely don't have to do it manually. Think of your Kubernetes cluster as being split into two distinct camps. First, you have the control plane, which acts as the intelligent manager of the whole operation. Then you have the nodes, which are the diligent worker machines actually running your containers. The control plane makes the big decisions, like scheduling and scaling, while the nodes, which can be physical computers or just virtual machines, execute those decisions using a little agent called a kubelet. For our practice today, we're going to use Minikube, which brilliantly packages both of these components into a single virtual machine right on your computer. Moving right along to Section 2, deploying your first app. Let's actually bring our application to life inside the cluster. We've got a super quick 3-step action sequence here. First, we spin up our local Minikube VM using Minikube start. By the way, you can also use the built-in Kubernetes dashboard for a great visual overview of your cluster if you want. Second, we instruct the control plane to create our deployment with kubectl create deployment hello node. Finally, we run kubectl get pods to verify it's working. When you run that create command, Kubernetes actively hunts for a suitable node, schedules your app to run there, and basically sets up a safety net to restart it if it ever fails. Now, looking closely at the official Hello Minikube documentation, we can see that our Hello Node deployment will continuously check our container's health. The deployment manages what Kubernetes calls a pod. And a pod, it's simply a logical wrapper around your container. By using a deployment rather than just booting up a pod directly, you get this amazing built-in self-healing mechanism. Literally, if your container crashes, the deployment controller automatically steps in and replaces it. Section 3, exposing with load balancers services. Okay, so our app is running happily in its own isolated little network bubble. But how does the outside world actually get to it? Let's sort that out. Here's the crucial thing you need to know. Pods are mortal. They die, they get replaced, and their IP addresses change constantly. So we absolutely must use what's called a service as a stable front door for our users. When a worker node dies, the pods on it are lost for good. When new ones spin up, they get entirely new IP addresses. A service gives us a permanent IP and intelligently routes all that incoming traffic only to the currently healthy pods. It's a real game changer. By executing this specific command, kubectl expose deployment hello node with the flags -type equals load balancer and -port equals 8080, we confidently instruct Kubernetes to open up port 8080 to the outside world using an external load balancer. Notice that type equals load balancer part? In a real cloud environment, this actually provisions a physical load balancer. But here on our local Minikube, it simply maps the service so we can access it directly from our own machine. The terminal output confirms our service's creation right away. It also reminds us that on Minikube, we can easily access it using the Minikube service command. You can see the cluster IP assigned there, and once you type Minikube service hello node, boom, a browser window will automatically pop open, serving your app's response. It is just a fantastic, instant way to verify your work. All right, Section 4, scaling your replicas. Our application is getting popular, so it needs to flex and grow to handle all this new incoming traffic. Let's scale it up. Scaling up simply means we're bumping up the number of replicas. And a replica? It's just an identical, totally swappable instance of your app container running inside a pod.
Because these replicas are completely exchangeable, the front-end system honestly doesn't care which exact back-end replica it talks to. This right here is the true power of container orchestration.
With just one simple command, Kubectl scale-replicas equals 4, we instantly command the control plane to multiply our application from a single instance right up to 4. The deployment controller immediately notices that, hey, the desired state is 4, but the current state is only 1, so it gets right to work scheduling 3 brand new pods on our available nodes.
The terminal output immediately confirms this reaction, proving that our desired state of 4 replicas now perfectly matches our current running state. And remember that service we created just a minute ago? It seamlessly detects these 3 new pods and automatically starts load balancing user traffic across all 4 of them. No manual reconfiguration required whatsoever.
Section 5, Zero Downtime Rolling Updates. It's time to upgrade our app to a brand new version, and we are going to do it without dropping a single user connection. This timeline really maps out the sheer brilliance of a rolling update. The system incrementally replaces old pod instances with new ones, ensuring the new ones are fully ready to go first. Having multiple replicas, like the 4 we just scaled to, is a strict requirement for this to work. Kubernetes will bring up a new pod with the new software version, patiently wait for it to become healthy, and only then terminate one of the older pods. As the documentation lays out, if a deployment is exposed publicly, the service acts like a super smart traffic cop. It only load balances traffic to the available updated pods. This means users who are actively clicking around on your app will experience absolute zero downtime. And what if the new version has a critical bug? Well, Kubernetes keeps a history of your updates, allowing you to easily hit an undo button and execute a rollback to the previous stable version.
Finally, Section 6, Cleaning up your resources. Our application's journey for this explainer is complete, so let's practice some good cluster hygiene and clean up our environment.
It's a really fast 3-step teardown sequence. We safely delete our load balancer with Kubectl delete service, remove the application pods with Kubectl delete deployment, and gracefully shut down the Minikube virtual machine using Minikube stop. It's incredibly important to delete your services and deployments to free up those resources. Now, if you want to come back and learn more later, you don't actually have to delete the entire Minikube VM. Simply stopping it is totally fine. So, you now have the foundational tools to literally command a Kubernetes cluster. The only question left is, what amazing system are you going to build with it? We've taken an app, brought it to life, exposed it to the world, scaled it up to meet demand, and seamlessly updated its software. I highly encourage you to open up your terminal and try running these commands for yourself. Until next time, happy orchestrating.